Okay, in the last video we learned how to graph an exponential function, and more specifically we learned how to graph exponential growth functions where the curve moved sharply up as we went left to right. In this particular section we're going to add in some shifting components, and as you may recall from absolute value and graphing quadratics, we could have this h and this k that is put into the graphing of it, and it makes the graph move left to right or up or down based off of the values of the h and the k. Well, we're going to have a similar situation here with exponential growth functions. Now, the main difference is when we had an absolute value or we had a parabola, what we were dealing with was we had a vertex. Okay, and so when we were shifting it, the h and the k was actually shifting the vertex left to right or up or down. In this particular case, however, the h and the k are not necessarily going to be shifting a specific vertex, but they're going to be shifting all of the points on the graph simultaneously, just like they were in absolute value and quadratics, but we don't have a specific point to base that off of. So we're going to have to make the shift to all of the points that are given to us or that we find in our XY t-chart. And I guess the simplest place to start would be with our y-intercept. Now, there's two ways to graph this. You could t-chart the entire thing, or you could graph the base graph and then shift it based off of that. But let's first of all take a look at the h and the k. Now, you can see here that we have an h and we have a k value. In our original function, y equals a times b to the x power is still there. Now, if we recall from previous lessons with h and k, the h actually makes us move left or right, and if you recall, that is going to be the opposite of whatever the sign is. So if it says x minus 2, that means we're going to shift to the right 2. If it says x plus 2, we're going to shift to the left 2. So remember, that's an opposite sign shift. Okay. Now the k just does exactly what it says, except it's going to be up or down. And whatever sign is with the k is going to determine whether it goes up or down. So we need to remember where the shifting is going to take us. Okay, so now we take a look at an example here. We have y equals 3 times 2 to the x power minus 1 and then minus 4. So you can see the exponent here is x minus 1. So the h is being represented by that 1. So we can see here that the h is equal to 1 and that the k is equal to negative 4. And so that means we're going to shift this 1 to the right and down 4. Now, we've got two choices here. We can either graph that function first, 3 times 2 to the x power, and in the example graph that we have, that's exactly what we did. We took our original graphing parts and we just simply graphed this exponential growth function first, and then based off of the other components, the shifting 1 to the right and down 4, you can see here that we've simply taken each of the points, shifted 1 right, and then down 4 to come up with our new parts. Now, one extremely important part here as well that you should recognize is that not only did we shift the entire graph down 4, but we also shifted this asymptote. So if we go down 4, the asymptote also shifts down 4 as well. So that's an extremely important part for us to remember. We don't want to try to graph this and keep the original asymptote. it's going to make our curve look really funny. So that is one way to graph this. Now, if you wanted to t-chart the entire graph, so if you wanted to put x value in for 3 times 2 to the x minus 1 minus 4, and then come up with a y value that way, and just t-chart the whole function and get one graph, you're more than welcome to do that as well. So, and we'll take a look at the different types of different types of ways to do that in class as you see fit. So let's go ahead and take a look at sample problem number 2. Go ahead and try this on your own first. So you can pause the video at this point, and if you want to t-chart the whole thing, feel free. Or you can graph the original function and then add the shifting component to it afterwards. So go ahead and take time to do that now. Okay, what I'm going to do is similar to the example above. I'm going to go ahead and just graph the original base function of y equals 2 times 3 to the x. When I do that, it gives me the base function that I'd been doing in previous lessons. So if I do that, I'm going to get a couple simple points. First of all, I know that that value of 2 is the a value. It's going to be my y-intercept. If I plot -1 for that, I'm going to get roughly 2/3. So I'm going to give kind of a guesstimated value. And of course, if you need to t-chart these, feel free. Or if you need to show your work, you do that as well. If I t-chart x is equal to 1, that's going to give me 6. And so what I have here is just this original graph, and I'm just going to kind of represent it with a quick little dotted exponential function, because that's not truly my answer. I still have these components of the function to deal with, so my answer is not going to be the red dotted graph. I have to add some shifting components here. So in this case, you can see that our h value is x minus 2, so that means our h value is actually a positive 2, which is going to shift us 2 to the right, and our k is a positive 1, so our k is actually going to shift us 1 up. So from this point, I'm actually going to take each point on the graph and shift it over 2 and up 1, over 2, up 1, and over 2 and up 1. Now, one of the most important parts about graphing this correctly is not only did our whole graph shift up, but so did our asymptote. So our new asymptote is now 1 higher, so we had to go up a positive 1. And so now when we graph our new graph, you can see here that as this gets closer to the asymptote, it now has to move to the left like that. And so the blue graph on this particular function is the final answer. And you can always plug this into your calculator and see that you got the right result as well. So that is a graphing example for exponential growth functions that have been shifted, and we're applying that previous knowledge of the h's and the k's and how they shift a graph from previous lessons. So get some practice doing some exponential growth functions with some shifting components on the worksheets in Moodle.